Now we're getting into the multi-step equations because they're called multi-step because they're not as easy to do and they involve quite a bit more operations. In this case, we have a variable on both sides. So that's why really we're calling it multi-step because we have to bring all the variables to one side, isolate them, do some simplification, and then go from there. Now it's basically the same as the other ones we've been doing. I mentioned before the whole goal is simplify and isolate. What I mean by isolate, bring all the x's on one side, bring all the constants on the other, and then continue. So 6x, I want to get this 4 onto that side. If I subtract 4 on this side, if I subtract 4x, sorry, I'll leave the minus 7 there. Since I did it to this side, I'm going to do it to this side. And we'll leave the 5 there. I'm not going to touch those yet. So here we get canceled out. 6x minus 4x equals 2x plus 5. We said those canceled out. We're at minus 7 here. Continue. We want this x alone. 2x plus 5 minus 5. Whatever we do to the right, we do to the left. So don't forget, immediately subtract 5. Notice that this is not multiplication. A lot of people think this sometimes that this is multiplication. It's not. You're adding and subtracting. I usually like to be very clear when I'm multiplying, either by using brackets or the big period sign. Dot. So 2x, that cancels out to 0, is equal to negative 7 minus 5 is negative 12. I multiply this side by a half. I multiply this side by a half. This side cancels out. We get 2x left alone equals negative 6. Sorry, cancel that. We already canceled out, so we get x equals negative 6. Of course, plug that into the equation and test it out. Make sure left side balances with right side. We are definitely taking it up a notch here. So since I'm short on room, I'm going to use arrows here. Here we're looking at some quite a bit more complex equation. In a way it's more complex, but in a way it's not. The first thing we want to do is think of what we're going to do is find a common denominator for these so that we can do some multiplying. Actually, really, we can do the common denominator for all sides, but I'm going to focus on this left side first. So if I have a common denominator, I can do the cross multiplication trick. So if I go 3 times x plus 3 plus, that's that plus there. Let's just go here. And here we cross multiply 8 times x plus 1 over. And now since basically what we've done here is to get a common denominator, the common denominator is going to be 24 because we multiplied 8 times 3. So if you divide 3 divided by 24 is 1 over 8, and there's that 1 over 8. 8 divided by 24 is 1 over 3, and there's the 1 over the third right there. Next, we have this big thing here on the left. So let's go 3x plus 9. We're going to expand. Multiply there, then here, plus 8x plus 8 all over 24. We're still doing the left side here. We haven't talked about the right side yet. So gather up all the x's, like terms, 8, 9, 10, 11x plus 17 over 24. Now what I'm going to do is bring that 3 back into the equation here because we're ready to do that. Again, here you can think of this as being 3 over 1, and we can do the cross multiplication trick. Well, here it doesn't really change. It just goes 11x plus 17. But here we get 24 times 3, which is 72. $11x is equal to 72 minus 17. Let's go up here since we have a little more space. Uh, 11x equals 72 minus 17. 72 minus 17 is 55. And we're lucky here because x works out nicely. Multiplied by 1 over 11 on this side. Isolate x, right? Right a side, left side. This cancels out. X equals 55 divided by 11 is 5. And of course, it's always, especially this one, it's more complicated. Plug it in into here and see if it balances out. So let's quickly do that. 5 plus 3 over 8 plus 5 plus 1 over 3 is equal to 8 over 8 plus 6 over 3, which is equal to 1 plus 2, which is equal to 3, which is equal to the right side. Beautiful. Now here's a doozy, because we have a fraction and then we have brackets. And now there's two ways of approaching this. You could expand this, but that almost seems counterintuitive because you're going from something that's nice and organized into something that's a little more chaotic. So when I see a fraction like this multiplied by, we're multiplying by whatever's in the brackets, you can also think of that as, you know, this whole idea of 3/4 x equals 2, something like that. What we did is we multiplied what the coefficient of x, which is 3/4, we multiplied by the reciprocal, and that canceled out. We can also do the same here, as long as we do it to the right side also, right? So let's do that. If we get multiplied by 4/3 times 3/4, and we still put the brackets in, of course, don't forget, equals -3 times 4/3. So we get now, this cancels out, and we get a nice d plus 2 on the left, because we're trying to isolate that d, equals, here we get -3 over 3 is -1 times 4. Now it's easy breezy. D is equal to -4 minus 2, because we subtracted 2 from this side, so we subtract 2 from that side. D is equal to -6. And of course, this is a little more complicated, so maybe we can test it. 3/4 -6 plus 2 equals left side, therefore 3/4 is times -4 is equal to -3, which is equal to right side. So we are okay. Therefore, D is equal to -6.